In the previous class, we have discussed about the Corral's law. Now, in this class, let us discuss application of Corral's law. Okay. So, first application is this Corral's law can be used in calculation of molar conductivity at infinite dilution. Molar conductivity at infinite dilution is symbolized by lambda m 0 or lambda m infinity. You can use either of them, anyone, okay, for a weak electrolyte. That means Corral's law can be used in calculation of molar conductivity at infinite dilution for a weak electrolyte. Because molar conductivity for a weak electrolyte at infinite dilution cannot be determined experimentally. So, this molar conductivity for a weak electrolyte at infinite dilution can be calculated using Corral's law. Now, I will explain this in Manipuri so that you can understand thoroughly. Aikoi mamangi class da Corral's law gi matang da fajana tamkare. Object Corral's law gi application namuk tamsi masigi class da. Ahanbagi application je Corral's law se weak electrolyte amagi molar conductivity at infinite dilution calculation to the sizinaba yai haibani Corral's law si. Aduna aikoi na khange madude molar conductivity at infinite dilution si lambda m 0 natraga lambda m infinity ani simrong da apamba amun hekta mahut sinba yai haidana. So aduna karigi Corral's law na weak electrolyte amagi molar conductivity at infinite dilution calculation tawuda Corral's law se sizina dorino haiba matamda aikoi na khange hanana madudi weak electrolyte amagi molar conductivity at infinite dilution se aikoi experimentally determine tawbu ngamde experimentally puthokpa ngamde experimentally puthokpa ngamdaba weak electrolyte amagi molar conductivity at infinite dilution ai si puthokya hai taradi Corral's law sizinaraga puthokpa yai. Aduna masi khangnaba aikona example la silorga yengsi example se nainarga yengsi to discuss and to understand application of Corral's law in calculation of molar conductivity at infinite dilution for a weak electrolyte. Let us take an example. Okay, so let us consider a weak electrolyte, acetic acid. This is called acetic acid. Okay, acetic acid. This is acetic acid. Formula is CH3COS. Aduna aikoi weak electrolyte acetic acid haibasi aikoi khana laurasi khanarasi. Hariba weak electrolyte acetic acid ki molar conductivity at infinite dilution si karamna puthokadage experimentally puthokadi yadrabani na weak electrolyte ki di puthokpa ngamdamni na kamai tarko puthokadage haiba matamda masida aikoi Corral's law apply tarasi. So by applying Corral's law, molar conductivity, this symbol lambda, this symbol lambda means that molar conductivity of acetic acid at infinite dilution, okay, is equal to ionic conductivity. This is the small letter lambda, which means that ionic conductivity of acetate anion. This is the acetate anion at infinite dilution plus ionic conductivity of hydrogen ion at infinite dilution. This is the Corral's law after applying to the acetic acid. Okay, aduna weak electrolyte by acetic acid sa masi agi aikoi molar conductivity at infinite dilution si experimentally hotpa weak electrolyte oibani na ngamdabani na madu aikoi khangna na ba aikoi acetic acid sida Corral's law panselasi. Corral's law pala matang dadi acetic acid ki molar conductivity at infinite dilution asi acetic acid sida yaruba acetate ion gi ionic conductivity at infinite dilution ne magi hydrogen ion gi ionic conductivity at infinite dilution ne ani se tinjinabaga manarani haibani masi equation 1 tholasi. This equation 1 can be arrived by knowing the molar conductivities at infinite dilution for the strong electrolytes potassium chloride potassium acetate and HCl, hydrochloric acid. Okay. Aduna masiki equation 1 molar conductivity at infinite dilution for acetic acid I say I could combine torga puthokpa ngamgadagi haiba matamda aikoina strong electrolyte potassium chloride ne potassium acetate ne hydrochloric acid ne makoichi strong electrolyte ngakni haiba strong electrolyte ahum sigi molar conductivity at infinite dilution khangabdi strong electrolyte ahum sigi molar conductivity at infinite dilution khangabdi makoi gi je khangaga moidi strong electrolyte in experimentally determine tawba ngamiko aduna high strong electrolyte ahum sigi experimentally determine torba molar conductivity at infinite dilution do madu khangaga puthokpa ngamdaba khang aikoi experimentally puthokpa ngamdaba weak electrolyte or acetic acid gi molar conductivity at infinite dilution se yo masi puthokpa yai sinero amai puthokani yang wadudi aduna high strong electrolyte ahum sida Corral's law apply toraga by applying Corral's law to this strong electrolyte potassium chloride potassium acetate and ICl it becomes molar conductivity of potassium chloride at infinite dilution is equal to ionic conductivity of potassium cation at infinite dilution plus ionic conductivity of chloride anion at infinite dilution. Okay, this is after applying Corral's law to potassium chloride. Okay, this becomes equation 2. Again, by applying Corral's law to this potassium acetate, it becomes molar conductivity of potassium acetate at infinite dilution is equal to ionic conductivity of acetate anion at infinite dilution plus ionic conductivity of potassium chloride at infinite dilution. This is the Corral's law after applying to the potassium acetate. Okay, this becomes equation 3. Again, by applying Corral's law to this third one, strong electrolyte hydrochloric acid HCl, how it becomes molar conductivity at infinite dilution for hydrochloric acid is equal to ionic conductivity of hydrogen ion at infinite dilution plus ionic conductivity of chloride anion at infinite dilution, how it becomes equation 4. Okay. Adding equation 3 and 4 and subtracting equation 2 we get. See what is equation 3 and equation 4. Now see. This is equation 3 and this is equation 4. Okay, equation 3, equation 4. By adding equation 3 and equation 4 and by subtracting equation 2. Clear? That means lambda potassium acetate infinite dilution, lambda hydrochloric acid infinite dilution, lambda hydrochloric acid potassium chloride at infinite dilution. Okay, so aduna hujik aikoi amuk yengasi equation 3 means molar conductivity of potassium acetate at infinite dilution. Equation 4 means molar conductivity of hydrochloric acid at infinite dilution. By adding means plus and subtracting means minus. Equation 2 means molar conductivity of potassium chloride at 0 concentration at infinite dilution. Okay. From equation 3 it is equal to ionic conductivity of acetate anion at infinite dilution plus ionic conductivity of potassium cation at infinite dilution. It becomes this. Okay, this part is for this and plus here molar conductivity of hydrochloric acid at infinite dilution is equal to ionic conductivity of hydrogen ion at infinite dilution plus ionic conductivity of chloride anion at infinite dilution. This part is for this. Okay, minus here again this is equal to this, which means that molar conductivity of potassium chloride at infinite dilution is equal to ionic conductivity of potassium cation plus ionic conductivity of chloride anion at infinite dilution. Okay, after simplifying, how it becomes here, it is same, plus sign is here, again this is also same, plus sign is here, this is also same, plus sign is here, this is also same, minus is sign is here. By multiplying minus to this, it becomes minus is equal to here, and multiplying this minus to positive, it becomes plus minus minus, it becomes here. Okay, so this is lambda naught chloride anion, ionic conductivity of chloride anion at infinite dilution, negative sign. Here also lambda naught chloride anion. Okay, but the sign is positive, so here the sign is positive, this is a negative sign, so these two can be cancelled to each other. Like that, here minus lambda naught K positive, here is plus lambda naught K positive, same but opposite sign, so these two can also be cancelled to each other. So the remaining part is lambda naught CH3COH acetate anion plus lambda naught is plus hydrogen ion. Okay, which is equal to molar conductivity at infinite dilution for acetic acid, because acetate anion and hydrogen ion, ionic conductivity, by adding both the ionic conductivity of acetate anion and hydrogen ion, it becomes acetic acid. Okay, acetic acid, molar conductivity at infinite dilution for acetic acid. Clear? So by experimentally determining the strong electrolyte potassium acetate's molar conductivity at infinite dilution and strong electrolyte hydrochloric acid's molar conductivity at infinite dilution, by adding these two and subtracting molar conductivity at infinite dilution for strong electrolyte potassium chloride, we can determine or we can calculate the molar conductivity of acetic acid, weak electrolyte. This is weak electrolyte. Clear? This is equation 1, that is molar conductivity at infinite dilution for acetic acid, a weak electrolyte. So thus we can calculate the molar conductivity for a weak electrolyte at infinite dilution by knowing the molar conductivities of strong electrolyte. Okay, by applying Correll's law. Clear?